Hello, this is Mr. Huber. In this lesson, we're going to learn about solving systems of equations by elimination. All right, we know that if we have an equation with two variables, we cannot solve that single equation in two variables. If we have a system, two equations with the same two variables, we can solve that. There's methods we can use such as graphing, substitution. Substitution replaces one of the variables with a value that then we have an equation with only one variable left we can use to solve. Elimination is also a way that we can get a system of equations to have only one variable. We can get one equation with just one variable. And anytime you have one equation with one variable, you can solve that equation for the variable that's left over. So we're going to eliminate one of the two variables and solve for the one that's left over. We can't just do that by magic. So how we can do that? We're going to add or subtract the equations from one another. We're going to see how that works in a second. So we eliminate a variable by adding or subtracting the equations from one another. Once we eliminate one of the variables by addition or subtraction, we can then solve for the variable that's left over. All right, first we want to make sure the equations are arranged in the same order so that the like terms are lined up with one another. So then when we add or subtract, we can only add and subtract and combine like terms. Okay. After we add or subtract the equations to eliminate a variable, and it doesn't matter which variable gets eliminated, we can solve for the variable that's left over. Right? If we have x and y, we get rid of x, we'd be able to solve for y. If we have x and y and get rid of y, we'd be able to solve for x. And then we can use that value, plug it back in to find the second variable. How are we going to know whether to add or subtract? That's a big key after we get the equations arranged properly. Okay? So if the coefficients of the variable we want to eliminate have the same sign, we'll subtract the two equations. If the coefficients have opposite signs, we will add the two equations. Again, for the variable we're trying to eliminate. So for instance, if we had 2x and a 2x, and we want to eliminate, we can see same sign, they're both positive, then I want to subtract these. Right? If I subtract 2x minus 2x, it cancels out. It would eliminate. Same if they're both negatives, as long as they're both the same signs. So if I had negative 3x and negative 3x, both the same sign, both negative, I want to subtract to get this to cancel out. So when I subtract the 3x, if I'm subtracting a negative, that's like negative 3 plus 3, which would also cancel out. And then if they're opposite signs, so if for instance we had 7x and negative 7x, it doesn't matter which one's the positive and which one's the negative, but if they're different signs, then we're going to want to add these together. So when I add these together, 7 plus negative 7 would cancel out to 0 and eliminate. So that's how we're going to eliminate one of the variables. Same signs, subtract, opposite signs, add. So let's see what that looks like in the context of a whole system of equations. Here we have 3x plus 2y equals 17 and x plus 2y equals 11. So we want to look at which variable would be able to eliminate. So look for one that has the same coefficient, here, 2 and 2. And they're both positive. They're both the same sign. So I want to subtract when I have the same signs. So when I subtract these two equations, you'll notice I'm going to put parentheses around it. So remember to subtract everything. You don't want to just subtract the 2y and 2y. You want to do 3x minus x, which is 2x. 2y minus 2y cancels out, equals 17 minus 11, which is 6. And when we eliminate a variable, we're generally left with an equation that's relatively straightforward to solve. 2x equals 6. Once I divide by 2 on both sides, I'll get x equals 3. And now once I have x equals 3, I can plug that into either of my two equations. I'm going to plug it into the second one just because that's a little simpler to work with. The x is just by itself as 3 plus 2y equals 11. So I took that equation and I replaced the x with a 3. And now I can subtract 3 on both sides because I'm trying to solve for the y. I get 2y equals 11 minus 3, which is 8. And when I divide by 2 on both sides, I get y equals 4. So my final answer would be 3, 4. Right? Write it as an ordered pair, x, y. That's my final answer. That's the one solution to that whole system. How can we find out if that's accurate? We can plug it in. We can always check our answer by plugging a 3 in for x, a 4 in for y. If I do that, 3 times 3 is 9, plus 2 times 4 is 8, 9 plus 8 is 17, equals 17. I could check it in the other equation because it needs to solve the whole system. So I'd have 3 plus 8, because 2 times 4 would be 8, 3 plus 8, which is 11, equals 11. So this works when I check it in both equations. Make sure it solves the entire system, both of the equations. So let's see another example. We have 4x plus 6y equals negative 4 and negative 4x minus 2y equals negative 8. So I can see here, these won't eliminate by adding or subtracting. 4 and negative 4, same coefficient, different signs. So now that they're different signs, I'm going to add the two equations together. So I'm going to add these two equations together. 4 plus negative 4 eliminates and cancels out. 6 plus negative 2 is 4y equals negative 4 plus negative 8 is negative 12. And now I can divide both sides by 4 and get y equals negative 3. Now I'm going to plug that into either one of my two equations to find my x value. I'm going to take the first equation. So if I take this over here, I have 4x plus 6 times negative 3 equals negative 4. And I'm just going back to substitution, right? I'm replacing a variable with the value that it's equal to. So give me 4x minus 18 equals negative 4. And then I can add 18 to both sides. So when I add 18 to both sides, I get 4x equals 14. And now when I divide by 4 on both sides, I'm going to get y equals, and it's a decimal or a fraction, it doesn't matter, it's 3.5. Okay, 3.5. Okay, you could even just reduce it to 7 over 2. Okay, so any of those answers will work. When you write it as your final answer, I don't care which one of those you use. So I would have 3.5 comma negative 3, for instance. Or again, you could write it as 3.5 or 7 over 2. Typically, I would say either the 3.5 or 3.5, especially if you're talking about where would it be on a graph or something like that. 3.5 is more reasonable than 7 over 2 to kind of figure out how that works. Or if you're going to plug it back in, it might be easier to plug in the 3.5, especially use the calculator to check those things out. Okay, so that'd be our answer, x comma y. We have a third equation here, system of equations to solve. And this one's going to require us to get to that first step I talked about, which is arranging the equations, right? If I just try to add or subtract these like they are, the equal signs aren't lined up. I got an x on the left here and x on the right there. That doesn't work. So I want to get the x and y both on the same side lined up. So I can add 8x. So I'll get x and y both on the left side. They can be both on the left, both on the right, one on either side, as long as it's the same in both equations. So in this, I'm going to add 8x and add 8x. So when I do that, this first equation is going to be 8x minus 4y equals negative 4. And my second equation doesn't change at all. 3x minus 4y equals negative 14. Okay? And now, if I see negative 4 and negative 4, same signs, that means I want to subtract. Make sure you're subtracting the entire equation. 8 minus 3 is 5x. Negative 4 minus negative 4 cancels out. And negative 4 minus negative 14. So over here we have negative 4 minus a negative, which is plus. So negative 4 plus 14. Negative 4 plus 14, which is 10. And then if I divide both sides by 5, I get x equals 2. Now that I've got x equals 2, go back to one of my two original equations. Don't use something over here where I added 8x on both sides. Take one of my two original equations. I'm going to take this first equation and plug it back into there. So I'm going to have negative 4y equals negative 8 times x, which is 2 minus 4. That's negative 4y equals negative 16 minus 4. Negative 4y equals negative 20. And now I divide by negative 4, and get y equals 5. So my final answer would be 2 comma 5. And remember, I can check that by taking 2 and plugging in for x and 5 and plugging in for y. Make sure you check it in both of the equations and make sure it's a solution for the entire system. All right, before we see another system of equations and an application of it, a little retail history. The first item purchased with a UPC barcode. So this is a UPC barcode here. Seen those before as you scan things across and it rings up prices. So that stands for Universal Product Code. Okay. This was first developed starting in 1973. There's some companies and some technology companies that put together an idea. They had tried other different systems to track things electronically. And in 1974 was the first time IBM was selected to come up with the first UPC barcodes to be used in an actual store. And you can see here in 1974 at 8:01 a.m. at this market in Ohio, Wrigley Gum, a 10-pack of Wrigley Gum, 5 sticks per pack, so that's 50 sticks of gum. It costs a total of 67 cents. There were other items in the checkout that day, but the first one that ran across the scanner with that UPC barcode was that Wrigley's Juicy Fruit chewing gum. All right. let's see a system of equations that we're going to have to write and then solve. So the math club bought 8 pizzas and 4 bottles of pop and spent $108. Broadcast 3 pizzas, 4 pop, and spent $48. We want to write and solve a system of equations. So we're going to write the first one for the math club. The math club bought 8 pizzas costing X dollars. So we're going to say the pizzas is X and the bottles of pop is the Y. You could use P and B or something like that. It doesn't matter. I'm going to use X and Y as long as you know what they represent. So 8X plus 4Y equals 108. Right? So 8 times however much a pizza costs plus 4 times however much a bottle of pop costs. That's what we're trying to find out. How much are those X and Y? So now there's a whole bunch of different numbers that I could plug in there for X and Y that would come out to 108. But we also know that 3 pizzas and 4 bottles of pop cost $48. So we have the same 2 variables in 2 separate equations. We have a system now that we can solve. The 4 y's will cancel. They're the same sign, so we're going to subtract those. 8x minus 3x is 5x. That cancels out. 108 minus 48 is 60. I divide both sides by 5. And I've got x equals 12. And now I can plug that into either of my 2 equations. I'm going to pick the second equation here. So my second equation now, if I bring that down, I'm going to solve that by plugging in a 12 for x. I'm going to have 3 times 12 plus 4y equals 48. So that's 36 plus 4y equals 48. I can subtract 36 on both sides. I get 4y equals 12. And if I divide by 4, I get y equals 3. So we want to make sure we answer the question now. So pizza is $12 and the pop is $3. And we could check that back into the situation. Okay, if I bought 8 pizzas times 12 plus 4 bottles of pop times 3, that would give me 108, and I could check the other situation as well. We wrote and solved a system of equations. So when we're writing and solving that system of equations, figure out what the variables are, come up with your 2 situations that use those same 2 variables. When we have the system written, this process of elimination, if we have the same coefficient, that's one of the keys to look for. If we have the same number, and if they're same signs subtract, different signs add, once you eliminate a variable, solve for the one that's left over, and use that value to then solve for the second variable. That's your solving a system of equations by elimination.